technologies and use them to solve new problems.
Well, I think we've covered a lot of ground in this first part of our deep dive. From microwave absorbers to rocket fuels, we've seen how material science is pushing the boundaries of what's possible.
And we've only just scratched the surface.
Exactly. So before we jump into the next section.
Okay. Welcome back. I'm still thinking about it. But it's very dangerous to get into
Materials that can make things practically invisible to radar to the stuff that powers rockets. It's clear that material science is shaking. And, before we get to the next paper, I want to go back to something you said about resonance ramps for those rockets. You were talking about how it's really important to understand exactly how those sound waves are interacting with the materials to get a good mix.
Right. It's not just about hitting the ingredients, it's the science of fine-tuning the frequency. All depends on the materials. So it's kind of like a conductor pattern. You know how features are taken up. How do they test the final product to make sure it's good?
That's a good question. It's like being a detective, gathering clues. They use all sorts of techniques, like microscopy, where they can actually see how particles interact, and spectroscopy, and rheology.
For something like rocket fuel. It's fascinating how much precision goes into it.
Precision is definitely key in material science. And speaking of precision, let's move on to this next paper. It takes us back to stealth technology, and it's all about something called non-resonant volumetric coatings. They're like a super RAM with even better performance.
Okay, so we're talking about making things even harder to find with radar, right? Tell me more about that.
So think of it like this. A non-resonant coating, it's like a stealth blanket that hides you from all kinds of radar, not just one specific frequency. See, the older RAMs, they tend to work best at absorbing a specific frequency, which is fine if you know what kind of radar you're up against. But non-resonant volumetric coatings, they're designed to absorb a whole bunch of different radar frequencies. So they're perfect for when you don't know what you're dealing with,
Or like a universal camouflage for radar. That's really clever. What kind of materials are in these coatings?
Well, this paper mentions this really fascinating mix: silica nanoparticles, fluoropolymers, ceramic coatings, and polyurethane elastomers. And they all play a specific role. For example, the silica nanoparticles, those are those tiny, tiny particles. They help give the coating its structure and make it better at scattering those radar waves.
It sounds like a really complex recipe. I mean, how do they even make these things?
It's definitely not something you could make at home. You need a deep understanding of materials, science, and engineering, You have to really know how to pick the right ingredients, put them together in the right amounts to get the properties you want. And that's where, that RAM technique we were talking about earlier, that really comes into play. It's crucial for getting those really well-mixed, consistent mixtures. That's what makes them work so well.
Okay, so we're back to that precise mixing again. But it's not just about what's in it, right? The paper also mentions how important the weight and thickness of the coating are.
Oh, absolutely. When you're talking about stealth, every little bit counts. You want it to be as thin and light as possible, especially if you're talking about an aircraft, but it still has to be able to absorb that radar effectively. It's a tough balance.
So how thin are we talking about for these non-resonant coatings?
Well, ideally less than 5 millimeters thick, and it should weigh less than 1 kilogram per square meter. Pretty impressive when you think about everything that goes into it.
Yeah, that's amazing. It really shows you how far material science has come. Do you think with all these advancements, we're getting close to completely invisible planes and tanks?
Well, complete invisibility, that's still science fiction. But these non-resonant volumetric coatings, they're a big step toward making things super hard to find on radar. They're better, they work on a wider range of frequencies, and they have the potential to be even thinner and lighter in the future. Who knows what's next, right?
That's true. Speaking of what's next, this next paper dives into a specific application of these advancements. It focuses on the Shenyang J-35. It's China's new stealth fighter jet. Creating a RAM for an aircraft, it seems like it would have a lot of challenges, right?
Oh, for sure. Designing a stealth aircraft, it's a huge undertaking. You have to think about how the air flows over it, the weight, how it performs, and of course, making sure it has a low radar signature. It's like this complex puzzle where everything has to fit together just right. And the RAM is a crucial piece of that puzzle. It's the stealth coating, the thing that helps the aircraft just blend in with all that radar noise.
It's amazing that material science is such a big part of making these cutting-edge fighter jets. So what can you tell me about the specific RAM they used on the J-35?
Well, this paper says that they're using this blend of enhanced carbon-based materials and something called advanced hybrid or emission organic material. So basically, they're combining the best of both worlds, right, to create a material that's really good at absorbing those radar waves and tough enough to handle all the stresses of flying.
It sounds like they've really pushed the limits of what's possible with material science. How about the performance? How does this new RAM actually work?
Well, from what they say in the paper, it's designed to be super thin. less than 5 millimeters, and really light, weighing less than 1 kilogram per square meter. And it has to be really durable, right, to withstand all that rain and wind and extreme temperatures.
Those are some impressive specs. It's clear that China is really serious about stealth technology. The paper also mentions that the J35 uses those non-resonant volumetric coatings, the ones we were just talking about.
Right, and they go into some detail about what exactly those coatings are made of on the J35. They're using silica nanoparticles, fluoropolymers, ceramic coatings, and polyurethane elastomers. And like we were saying, all those things together make a coating that can absorb a whole bunch of radar frequencies while still being light and durable.
I never really thought about all that goes into making an aircraft stealthy. It's not just the shape, it's the materials, the coatings, and all the science behind it.
Yeah, exactly. It's amazing what these scientists and engineers are doing, constantly pushing the limits. And the results, they're pretty incredible. They say the non-resonant volumetric coatings on the J35, they weigh less than 0.5 kilogram per square meter, and they can absorb a really wide range of radar frequencies.
Wow. That's amazing. It's incredible to see how far we've come with stealth technology. Yeah. From those first attempts to camouflage things from radar to these high-tech coatings that can make an aircraft almost disappear. But it does make you think, doesn't it? What happens when warfare becomes less detectable? Is that a good thing?
Oh, that's a question people have been asking for decades, and it's not an easy one to answer. Stealth technology, it could make military operations more precise, less destructive, but it also makes things less transparent, and that can lead to mistakes.
Yeah, it's a complicated issue for sure. And these advancements in material science, well, they're creating as many questions as they are answers.
That's for sure. And those questions, they're important ones to think about. Technology, it's a powerful tool, and we have to use it carefully, ethically.
I like that. Well said. I think that's a great way to transition to the final part of our deep dive. We can delve a little deeper into those ethical and strategic implications and see what the future might hold for material science. Welcome back to the deep dive for the last part of our exploration into material science. We've seen how these incredible discoveries are, they're really shaping the future. But as you said, they also bring up some big questions, right? Ethical questions, especially with that stealth technology.
Yeah, you're right. It's like we've opened this door to all these possibilities, and now we have to figure out, well, what it all means, stealth technology especially. It could really change the whole game when it comes to defense and warfare.
It's like we're living in a science fiction novel, except it's happening now. So as these technologies get even more advanced, how do you think they'll impact global security?
Well, we're already seeing a lot of countries putting a lot of resources into developing, more and more sophisticated stealth capabilities, and that's kind of leading to an arms race in a way. But the thing about stealth is that it introduces this uncertainty. If you can't see what your opponent's doing, it's harder to figure out what they're going to do next or even what their goals are.
It's like playing chess, but you can't see all the pieces.
Yeah.
Right. That lack of transparency, it can be dangerous, especially with all the geopolitical tension in the world.
Exactly. It creates this situation where it's easier to miscalculate things, to escalate a conflict. So it's really important to have those open discussions. International cooperation is key when it comes to technologies like this.
Okay, so how do we make sure that these advancements are used responsibly? It feels like we're in uncharted waters here.
Well, there's no easy answer, but I think the first step is, it's acknowledging the risks. And then, having those open conversations about the ethical side of things. And we have to include everyone in those conversations, scientists, engineers, policymakers, even the public, because this affects all of us.
So it's about creating this sense of global responsibility, recognizing that these advances have the potential to impact the whole world. We can't just leave those decisions to, government and the military.
I agree. And it's not just stealth either. As material science keeps advancing, we're going to see more and more breakthroughs that have the potential to really change things ethically and for society as a whole. We need to start thinking about this now, create some kind of framework for responsible innovation.
It's interesting. These deep dives, they often take us beyond the science itself, right?
Yeah.
And make us think about these big picture questions. It's a good reminder that scientific progress doesn't happen in a vacuum.
That's one of the things I really love about exploring science. It's not just about the facts, it's about understanding the impact those discoveries have on the world, on us.
So as we're wrapping up this deep dive, I'm curious about your thoughts on the future of material science. What are you most excited about?
Oh man, the possibilities are endless. I think we're at the beginning of this whole new era where we'll be able to design materials with this unbelievable precision. Imagine materials that can repair themselves or adapt to their environment or even, convert energy super efficiently.
It sounds like something out of Star Trek.
Yeah.
But, it's all based on real science, right? It's the power of materials.
Yeah, exactly. We're not just finding materials anymore. We're engineering them at the atomic level. And that's going to open up so many doors. Revolutionary medical treatments, sustainable energy solutions, even building materials that can survive anything. It's an exciting time to be in this field.
It's exciting and a little bit scary too, to be honest.
Yeah.
What would you say to someone who wants to learn more about all this?
I'd say jump right in. Materials science is fascinating, it's changing all the time, and it affects every part of our lives. I don't care if you're interested in technology or medicine or even art, there's a place for everyone in this field.
I like that.
Yeah.
Well, it's been fantastic exploring all these groundbreaking discoveries in material science with you. It's clear that, well, this field is shaping our future.
It's been a pleasure. I always love sharing the amazing world of material science.
And to our listeners, thanks for joining us on this deep dive. We hope you enjoyed exploring the world of material science with us. We'll see you next time.